when we have problems with integrals involving sine and cosine, is when we get an even power with sine or cosine. That's when we run into some problems. When we have an even power with sine and cosine. All right, there's no odd power for sine or cosine hanging around. That could be where we have just a sine to a power, even power, or cosine to an even power, or we can have a mixture of the two, but they're all even powers. And that won't allow us to break off a piece to have left over and then convert everything back to the other variable. So that doesn't work here. All right, you could strip off a cosine squared, but we need to be able to strip off just a single cosine. And unfortunately, we're going to have an extra single cosine that we can't do anything about. So that's a bit of an issue there. So when we do that one, we have to go back in this situation, and we're going to be working with these identities. That cosine squared and sine squared identities in terms of a half angle. That's what we're going to have to go back to. And we may find ourselves having to go back to it a couple of times. So with that in mind, there's a couple of little algebra formulas that are useful to just have so we can speed things up a little bit here. And that is, if we take a quantity squared, that multiplies out as a squared plus 2ab plus b squared. And if we have a difference, a minus b quantity squared, that multiplies out to be a squared minus 2ab plus b squared. And so these are kind of useful because what we're going to do here with this cosine to the fourth is first express it as in terms of its cosine squared. So cosine to the fourth is cosine squared squared. And then I can apply the substitution that I just mentioned up above, that the square of a cosine is 1 plus cosine of the double angle, all divided by 2, quantity squared. And then I just want to multiply that out. So on the one hand, the 2 squared is just going to be 1/4. That'll be out front. And then 1 plus cosine 2x, I'm just going to use my square formula here to do it very quickly. So that'll be the first thing squared, which will be 1 plus twice their product, 2 times 1 times cosine 2x, plus the second thing squared. Dx. And so now I've ran into another square. So I have to expand that one out. All right, I ran into another square here. So I'm going to have to expand that one out. The rest of the stuff I can go ahead and just break up as an integral. But this last piece I'm going to have to go further with. So at this point I'm ready to break it apart. So on the one hand here, I would have 1/4 integral dx plus 1/4 times 2 would be 1/2 integral of cosine 2x dx plus 1/4. And then for cosine squared, I have to use the identity again. 1 plus the cosine of twice the angle. In this case, it's going to be twice 2x all over 2. So 1 plus cosine of twice 2x, which will become 4x, all that over 2 dx. Okay. So let's just go through here. I'm going to come down a little bit and start working out what I know. Integral of dx is just x, so that'll be just 1/4 x. For cosine 2x, we have to do substitution. Let u be the inside piece, 2x. du is going to call for a 2 to go with our dx. So that means this integral here, I'm going to have a 2 to go with my dx to carry the substitution through. So I don't have a 2, so I go ahead and put the 2 with the dx and then divide by it out front. So that'll actually be 1/4 integral cosine 2x times 2 dx. So now this is ready made. It's cosine u, du. So integral cosine is just sine. So this would be plus 1/4. Integral cosine is sine. So I'm going to have sine 2x. Sine of u. Integral cosine u is sine u. So u is 2x, so it's sine of 2x. Okay, so those are the first two parts worked out. Let's go back to this one here. I'm going to multiply through by the 1/4 and do some factoring out here. So that's actually going to be 1/8 integral dx plus 1/8 times the integral of cosine 4x dx, which I'm again going to need to do a substitution with. So I let u be the 4x, du will call for a 4dx, so I need a 4 to go inside the dx. So I don't have it, so I put it there, but then I divide on the outside. So that one, when we carry everything through, will actually be 1/32 integral cosine 4x times 4dx. So it's ready to carry its substitution through as well. Okay, and now we're ready to put it all together. So a lot of work here, because we have to keep adjusting every one of these squares down to something else. Okay, and so putting it all together here, this would be plus 1/8 x plus 1/32, and substitution's already set up. Cosine, integral cosine is sine, so that would be sine 4x, and then don't forget, of course, your plus c. So there's just a little bit more to do here, a little bit more to do. And that is, we do have like terms here, 1/4 x and 1/8 x. So we put those together. 1/4 and 1/8 is 3/8 x plus 1/4 sine of 2x plus 1/32 sine of 4x plus a constant. And so now we finally have our integral worked out there. We have our integral worked out. Okay. 3/8 x plus 1/4 sine of 2x plus 1/32 sine of 4x plus c. Okay. So that is our integral of cosine to the 4th. Cosine to the 4th. Okay, so definitely a whole lot more work if we can't just strip off an odd power to let us do our normal type of substitution stuff. A lot more work. And this was a cosine to the 4th. You can imagine, what if it was cosine to the 6th? Well, then you'd have this stuff cubed, and you'd have to cube that stuff out. You're going to have some other powers that you're going to have to deal with. Okay, so again, could be some more work. Definitely some more work. But this is the idea of how we handle these even powers. Fortunately, they're a bit of a pain in the butt.